Okay, so let's recap what we've done so far. So in Chapter 2, we did limits, kind of beginning to bridge the gap between algebra and calculus, how we move from 2 points to 1 point. That was the whole point of limits. Then we started looking at derivatives, and all through Chapter 3, we did all those different kinds of derivatives, all the different power rule and exponential and logarithmic, and then what else did we do? Product rule, quotient rule, chain rule, implicit differentiation. So we did lots of different kinds of derivatives. And so what was the point of that? So let's talk about that's what we're doing. What we're doing in Chapter 4 is kind of what are we using all this derivative information for? So what is the first thing we think of when we think of derivative? Slope. Derivative.
Progression.
Yeah, derivative is a slope, otherwise known as a rate of change. So that either one of those will work. And it's an instantaneous rate of change, instantaneous slope. So not between 2 points, that's algebra, where it calculates 1 point. So what do we know then about the first derivative? It's the slope of the function. All right, so the first derivative is the slope of the function itself. So that tells us what about the function?
Increasing and decreasing.
Where it's going up, where it's going down, and if we know when it's going up and when it's going down, then we know max and min. So first derivative, this tells us what the function is doing, up and down, or increasing, decreasing, and as a result of that, max and min. So we can use that, and that's what we're starting to use it for in this particular. So we can use that for a couple of different things. One is graphing. If we don't know what a function looks like, we can graph, check out the first derivative. Always, 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 what is required to know this information? Can you look at it and say, oh,
Sign chart.
sign chart, sign chart. You cannot know the answer in the back of the book without looking in the back of the book if you don't do a sign chart. Okay, so absolutely this requires a sign chart. And then we can use it for a couple of different things. We can use it for graphing. We can use it for finding something like what's the maximum profit, right? That's something we'd all want to know in a business. How many items do I need to sell to make maximum profit? So that's called optimization, and that's what we're working on right now. Was there anything else that we used first derivative for? Max, min, anything you want to find the max or min of graphing? I think that's mostly it, right? So what happens when we look at the second derivative? So this, importantly, is the rate of change of the function. If we look at the second derivative, what's that? Concavity, that's what it tells us. It's the derivative of the derivative. So this is the derivative of f prime. So it tells us, yes?
Somebody took the speech lecture out of the communications room.
Yes, I would love for you to have it back because I moved it out of the way.
Way.
Absolutely. Can you get past?
Yes.
Okay. So it's the derivative of the first derivative. So this is akin to, we use this all the time, we just may not think about it. You're driving down the road. You're going forward. That means your distance is, you can think of your distance as increasing, right? You're driving down the road, you're going forward. All of a sudden, a stop sign comes. What do? You slow down. Are you still moving forward? Yes. Your speed is slowing down. So deceleration is a second derivative. Driving forward, that's your first derivative. Slowing down is your second derivative. The reverse is then accelerating. You need to accelerate. Now you're increasing your speed. So increasing and decreasing your speed is a second derivative. Okay, so that means, so this is a rate of change of the function itself. So yes, concavity, because when we go to graph that, increasing speed says, here's my slope, and I want it to increase. So it gives us a shape to the curve. Yes?
So we're assuming in this analogy that the speed at which you're going is a constant rate of change, and that the slowing down or speeding up is a rate of change of the rate of change?
Yes, and it's constant for a moment in time.
Right.
Yes. So we have concavity and inflection points. Concavity gives us the shape of the curve. So if we have a slope that's increasing, it gives us that upward bowl shape. If we have a slope that's decreasing, right, the slope is flattening, that gives us that upside down shape. So we can use this for graphing. That's a primary place we use it. Where else have we used it? What do we call that inflection point? When we have something that's increasing and then starts to decrease? Remember what that's called in the business application? Like your sales are increasing, because you're putting in a lot of advertising dollars, and then at some point you keep putting in advertising dollars,
Let's
but
say break-even point, but it's not it.
not break-even
Yeah,
point,
it's
right?
not.
Diminishing returns, right? So diminishing returns is actually your inflection point, because it's saying, you know, the more advertising you put in, you're still increasing your sales, but it used to be a little bit of advertising in the beginning when nobody knew about your product. That made your sales really go up. But then after a while, a lot of people already know, so you keep putting in advertising dollars, and you're still reaching some people, but not as many, so it flattens out some. Yes?
So what would we call it if the opposite occurs to an inflection?
Where it's decreasing and then
Like you're
increasing.
putting in a certain amount of advertising, you're not really getting something for it, but after a certain point of advertising,
You do.
you're able to get on 12 o'clock.
Right. And
or
I don't.
NBC at 8
Right,
o'clock.
right.
prime
And I
time.
don't know the name for that. Maybe business people.
So this quote unquote diminishing returns.
Is all about diminishing.
Right, is always
It's all about,
diminishing.
right,
So
exactly.
it's
If it's the
opposite
reverse,
direction,
I'm
it's
sure there's
just
a name for it,
inflection.
I just, yeah, I don't know what it is.
Okay.
So we have diminishing returns, and then what's the last one? If we know that we have a min, I mean, we know we have a critical point here, so you have some critical point, and if we know that the concavity is up, what do we know happens at the critical point?
Absolute min.
It's a min. And if you know you have a critical point and it's upside down, then it's a max. So we also have the second derivative test here for max min. I think this is pretty much everything that's on the test. This is it. So it all ties together really nicely. It's all about rate of change, which tells us what the function is doing and what the derivative or the speed or the rate of change is doing. And we can put it together in a graph. We can answer some interesting questions about optimizing. We can look at diminishing returns. We can look at other ways to find max and min. Can anybody else think of anything else we've covered? I think this is mostly, there may be an application I'm missing, but we'll get to that. Okay, so this is kind of, so this is where we are, and right now we're talking about this piece, optimization, finding maximum profit or maximum area or minimum cost, things like that. Okay, so pause that.